Hello and welcome to the Happy Maths Hour. Toni Beardon will join me in just a moment. I managed to do we're in lockdown, so I'm controlling this on StreamYard, and as usual, I don't think we're going to have a program where I don't do something that's gone a bit skew. Today, it's all about we're doing effectively art. We're making stars, and we're using stars to find out about multiples and factors, about times tables. If you've got a child in your life who's struggling with learning their times tables, if you yourself think, I really wish I knew my times tables and I understood numbers better, this program is going to help you. And it's the Happy Maths Hour, so it's all about enjoying maths, loving maths, or learning to love maths. And we're always looking for ways to help you. So after the break, hopefully Toni will be with me. I'll have to maybe send her the link again, and see you after the break.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back. Welcome to the Happy Maths Hour. Now, Toni isn't here yet because I've managed to send her the wrong link twice. Finally, third time's a charm. I've managed to send Toni the correct link this time. Oh my goodness.
Caroline, I've
Yes.
been in other studios,
Oh,
all
dear.
on my own.
I'm sorry. I'm so sorry. Here we go. I'm looking for the correct background here, and there's you and me. There we go. That's our correct background for our show. And yes, I found the right link and I sent
Let's
it to
get
you
going.
kindly. Let's get going. So
Caroline,
today I was just telling them it's all about numbers. It's about number sense. It's about really learning how to learn times tables, finding out fun ways of learning them, and it's about connecting numbers together in the form of stars. Right. Sorry, Toni, go ahead. Shall we?
I was just going to say, should we advertise this as 17:05, because we never seem to start on time.
We pretty much got to stick at 5 o'clock. I do start on time. I kind of yeah, but we'll talk about that later. Well, we should just aim to always start on the dot. So yes, so 1700 hours London time is when it's supposed to start. Toni has a slideshow for us, and we're going to start investigating numbers. So if you've got children with problems with learning their times tables, who just don't get how numbers work together, who have difficulty with long multiplication and long division, we've got all kinds of ideas today to help you with that, and also to do a bit of art. We're going to make stars. So you could look at it as art, but is art maths? Is maths art? Where do the two cross over? How are you doing over there, Toni, with the...
Well, would you like to share my screen? Let's see. I think that's what we want.
Right, so while we're waiting for Toni to share the screen, let me think what else we've got. We've got actually a few games in the... Oh, here we go. Add to stream. All right, I've got the option. Woo! Here we go. Oh, that's not quite what we're looking for.
That's not quite what we want. That's my... Aha. This is what we want.
Right, okay, and that magic button there, there's me with my bad hair day. We both got COVID hair, so I'm not going to worry about that. As it is, I've got a mask. I'm in a place where I've got to stay with my mask on. So that's COVID times for you. Toni, so what is, so this is about, it's called Path to the Stars, and we're going to be making stars. Oh, so this is an activity which is literally a huge demonstration of the activity that we're focusing on today. This is done by my friends in a place called a museum called MACA, the Museum of Mathematics of Catalonia, and if you can see, they had a conference on the bottom right where you can see everyone sitting down, and above they had this lovely octagonal or decagonal shape, and where they could actually pass rope across, and they've done that, and they've connected all the points. They've connected, I haven't actually counted the points, maybe 20 points on there, and so they've drawn a star with the rope. Would you like to make a more mathematical observation than that?
I've just counted, Caroline. I think it's 16 points.
Right.
But isn't it beautiful? I mean, the fact they've got the skylight in the middle is wonderful.
Yeah, it is 16, yes. And yes, and this, if you ever do get a chance, if you're ever in Barcelona, I know people like to see the standard things in Barcelona, but actually this small museum is in a tiny palace in a little park in the suburbs at the edge of Barcelona. And the people that run it are amazing. It's open to the public on a Sunday, and it's open every day, but well, at the moment it's not, but it's still open on a Sunday, I believe. And the mass, you can just play. They've got what we call manipulatives. They've got toys you can get your hands on and just solve puzzles. You can just go around the place. And this is an example of one of the activities that they've come up with for this conference.
And we're going to talk about this very activity.
We are. Okay.
Now, we're going to first of all talk a bit about learning your multiplication tables, because it's something that is very often people discuss. They often say what a nightmare it was for them when they were children.
Well, I could never understand why I had to learn my multiplication tables. Even after I started in 16 years ago to oh my goodness. Oh my, there's something happening. Is it you? Is it me? Can you mute yours and see if that solves the problem, Toni? Mute your StreamYard. See if by you muting on StreamYard. Mute yours.
Caroline, I don't think so, but I'm going to...
Yes, on StreamYard where you shared the screen. Click mute.
Caroline, it's just
Oh, okay, whatever you've done worked. I don't know if I can hear you though. That's the only problem. We can't hear you, so you must have muted. Yes, you've muted, but if you can put the screen back to the way it was so we can see it, at least I can. Can you put your ear things in?
While we're trying to sort this out.
Yes, but if you mute, Toni, I can keep talking. If you just mute yours for a moment. Okay, so I'm just trying to think what the next slide was there. And I don't remember what the next slide was. Toni is working on that, but Toni, perhaps you could plug in. Yes, no, it works now.
Caroline, can you hear me now?
I can hear you now. Yes, that's great. Don't know what happened there. That's weird.
Caroline, can you hear me?
Yes, I can hear you. Can you not hear me? We've either got sound or we've either got microphone or... Oh dear. Let me see if someone could comment to let me know if you can hear me. Then I know that my sound is working. I don't seem to have anyone else in the studio what. Toni, can you hear me? Can't hear me?
Yes.
Oh, you can. Oh, fantastic. Okay.
We seem to be back to normal.
Okay, can we have the next slide then?
Yes.
Okay. Right. Oh yes, I was saying that I didn't understand why I had to learn my times tables. I'm one of those. I was one of those. So like finally, after about 10 years of facilitating the learning of mathematics in a fun way, using balloons and soap bubbles, I finally understood why. You need fluency in order to do those. People dread things like algebra. Well, if you are fluent with your numbers and you know your times tables, algebra makes so much more sense. You think, oh well, if that, and also things like simplifying fractions, those sorts of things. If you know your times tables, but any time you have to deal with numbers, and if you want to make everything simpler, if you know how the numbers work together, and you really know, especially up to 12 by 12 times 12, it's
Caroline.
Yes,
Caroline, I would like to say more than that.
Go on. That's my story about it. I'm just telling my story. So go on with the academic side, Toni, please.
Well, it's not particularly academic. It's more about people and learning.
Yeah.
I mean, I've coached people for examinations at age 16 and 18. And I think knowing your multiplication tables could make a whole grade of difference in your final high stakes exam. Because if you don't know them, you're going to be that much slower.
And also you'll make mistakes because things that are obvious if you do know them aren't obvious if you don't.
And as Caroline said, it's not just arithmetic, it's the algebra too. And what I would say is that a good teacher makes learning tables fun and not a nightmare. And parents should remember too that it shouldn't be something that children just hate doing. There's plenty of ways to learn your tables, these multiplication facts, without pain. In fact, in a fun way. Now, I do recommend that video. James actually explains multiplication tables and multiplication facts brilliantly. And the important thing is to learn whatever maths it is, but particularly this one, with understanding. Okay, well, one way to make it fun is to play games. And there are lots of the games that don't require you to be on the internet. But here's a link to one that does. This is a computer game. Lots of children love their screens and computer games. There's a computer game that helps you practice mental arithmetic, and in particular, multiplication tables. Now, the point about tables is mindset. If you think, yes, I can, you'll be able to do it. If it's, oh, you're one of these people, and I've met hundreds of them, who say, I could never learn my tables. It was self-defeating. The reason they couldn't learn their tables or learn the multiplication facts was because they didn't believe in themselves.
And it's not just,
if they want to,
well,
they can do it.
Yeah, and I've got friends who, as you say here, they can learn the lyrics to songs. That's something I have never been good at. And then of course that's my own self-limiting belief, really. But people who are good at art, who are good at writing, who are good at performing, but can't do maths. Well, it's just a matter of engaging that mind in a way that if they get those basic skills that they have with the things that they're interested in, then all of a sudden, actually maths maths is exciting, it is creative if you view it in that way, and if you have the basic skills and the foundation and all. It's so much fun. It's truly fun. As long as you want to do it and you love doing it.
There have been fashions for people to believe, even teachers in primary school to believe, that you didn't need to learn your tables, or you could do something about it, but you didn't need to make it a big thing. But actually, I think that was wrong. But it shouldn't be a frightening, off-putting experience for children.
And there are lots and lots of games, and we're going to share a bunch of links later. We're going to add them to this broadcast afterwards, with lots of links and ideas to play games to learn your times tables.
And I don't usually stress speed in mathematics. It isn't the kid who finishes first who's necessarily the best mathematician. Often they're not. But instant recall of multiplication facts is important. So that's a place where, you know, just being able to do it quickly is important.
So what are we doing after the break? Yes, fizz bars. Everyone knows about fizz bars. We're going to talk briefly about fizz bars. We're going to go to the break. So what can you? So fizz bars is a game where you say fizz for every multiple of 3, buzz for every multiple of 5. You're going to have lots of hilarity in a room, and I've actually seen it described as a word game. Isn't that wonderful? A word game that grown-ups play as a party game. That's actually all about multiplication and times tables and factors and multiples, and it's loads and loads of fun. And that is an excellent way. You don't have to just do it with 3 and 5. You can choose any number you like, and you can add extra words. You don't need to just have 3 and 5. You could have 3, 5 and 7. You could add whatever numbers in and make it a different word, and just have lots and lots of fun. Play it on a regular basis. Play it after supper every Thursday night at home, and you will get your children they'll start to know and really enjoy learning their times tables. Toni, what are we going to do next? Because I'm going to introduce that before we're going to be a little bit late on the break.
The FizzBuzz, that Wikipedia link has lots of variations of the game, and many of you will have played it before. And it usually ends up with people rolling around with laughter and really enjoying it.
And you can play it on a regular basis. Oh,
now
right.
The next thing is the path to the stars.
Okay, so we're going to talk about the stars after.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Okay, Toni, I have just realized I haven't shared the link. So if you wouldn't mind talking about this while I just do the link sharing of the program, that'd be amazing.
Right. Now, a lot of what we're talking about this afternoon will be about this path to the stars idea. And in the museum in Barcelona, you saw a star with 12 points made with string or rope. Now, this one is actually made with 5 points, and it's a pencil and paper production. Now, I've actually just thought I should actually change this slide, because it's not a matter of drawing the star, it's a matter of drawing the pattern you see there. It's a star with a pentagon in the middle, okay? And can you do that with 5 points and joining the points with chords of the circle, and make the star without taking your pencil off the paper or going over the same line twice. And when you've done it with 5 points, can you do it with 6 or 7 or 8? Do it in different ways. And it's, again, and you'll see why, it's all about multiples. Now, here's another star. Now, this star has got 7 points, and I've written the days of the week around. So it's similar to the one you just saw and the one you saw in the museum in Barcelona. But now, follow it round. So if you go from Sunday to Tuesday to Thursday to Saturday to Monday to Wednesday, we're in the second week now, to Friday to Sunday, get back to where you started. You do that without taking your, well, if you drew it without taking your pen or pencil off the paper, and it's, as far as this is concerned, it takes 2 weeks. So what you've got there is a cycle that involves 7 days of the week. And we're very used to that cycle. We talk about the day after tomorrow. And that, well, it's Monday today, so the day after tomorrow is Wednesday. And what we're doing here is going each time to the day after tomorrow. We're going counting in 2s around this circle. Now then, imagine the same 7 points on the edge of a circle and joining them up, but not going to the day after tomorrow, not going from Sunday to Tuesday, but going from Sunday to Wednesday. And each time you do this star, you go not the day after tomorrow, but you go on 3 days. So you go from, now I've put the numbers here. So if you were to number these points, 0, 1, 2, 3, 4, 5, 6. By the time you get back to the beginning, you've gone around 7 points, and 7 is just like Sunday. Okay? So as you go through the days of the week, as you go through 7 days, you come back to the same day of the week. And so what we have is 7 cycle. In maths, cycles are hugely important. They crop up all over the place. And there's even a whole branch of mathematics or a topic called modular arithmetic. And in this arithmetic, 14 is the same as 0. 8 and 15 are the same as 1. Okay, so let's...
Yeah, so the comparison is exactly as you've shown. It's Sunday is Sunday is Sunday. It isn't, if you've got 21 days, it's still Sunday. The 21st day is still Sunday. And I really like that, a real life comparison. And I also like the fact that if you skip 2 days, you go on a 2-day hop like you do on the left, it takes 2 whole weeks to get back to Sunday. And if you do the 3-day hop, it takes 3 whole weeks to get back to Sunday. And there you go. You've got how the stars and the timetables work together. You can see that 2 times 7 is 14. That's the 2 times table, basically, if you're skipping one, going to the second. And you're looking at the 3 times table. If you're skipping 3 to get through, your points are representing the 3 times table, and you can just pop around, and that gives you can follow the 3 times table on that one, and then you can continue on, as you will see, to work on other different amounts of dots on your circle.
So you're going from 0 to 3 to 6 to 9 to 12 to 15 to 18 to 21. And can you see, we actually went round the circle 3 times. It took 3 weeks.
Yeah.
That's lovely, I think.
Yeah, I love it too.
Now, here's a nice picture. We've been looking at 7-point stars, but this is a 5-point star. And we've got 5 people, and they're each pointing one finger at one person and the other finger at another person.
Well, that's a beautiful activity to get 5 children to do that, and you actually create the star and figure out who they're pointing at. It's lovely.
Mm-hmm. Now here we've got another pattern. It could be part of a fractal and a stage of a fractal, because in each pentagon, that's the 5 points, you join up the points and you make a star, and then you make another star inside, and another star inside, and another star inside.
So we're back to my doodling in the margin again here, Toni, is see how many times I could make the pentagram within the pentagon, and then another pentagram within that pentagon. And that's a lovely challenge, to make as big a pentagram as you can, and then see how many you can make within the pentagon that gets formed in the middle. Absolutely. It's a lovely activity. And yeah, Toni's got it as a question there. Make your big pentagram as large as possible. Then how many can you fit inside? And just see what techniques you can use to make the smallest possible pentagram in the middle.
And you can travel to eternity in your brain with mathematics. I mean, you can imagine going out as well as in. Imagine embedding the star you see in a bigger one, and that's embedded in a bigger one, and you just go out to infinity. It goes on and on. You needn't stop. I mean, you'd run out of time. You'd live 100 years and you'd never finish it. You'd never be anywhere near.
It would take an infinite amount of time to do it. So never ends. Only in mathematics. And that is one of the joys of maths. It does actually go on forever. And in your mind, you can attempt to visualize it. So that is one of the joys of it. And it works for, so many lovely questions.
Okay, now, last week or the week before, we talked about games. And this is a well-known game, the scissors, paper, rock game. But usually, well, most people know the scissors, paper, rock. But did you know you can play it with 7 elements? And you get cycles here. This is why I showed this. So just look at this cycle. This is a 4 cycle. So you've got rock, blunt, scissors. Scissors, they soak up, they cut the sponge. Sponge soaks up the water, and water wets rock. So that's who wins That's a what it's see which element bins which other element. And if you look into this pattern, you see not only 4 cycles, but you can see 3 cycles and 5 cycles. It's lovely. Oh, you can even have a 7 cycle that goes all the way around the edge. Okay.
And the order matters, so you can actually look and see how many different cycles you can find and how many elements there are in each cycle, and see if you can find them all. That's just one very simple activity you can do, and play the games with those.
Notice that the arrows are one way, because one of those always beats another one or is beaten by another one. And so each one beats 3 other elements and is beaten by 3 other elements. Lovely structure there.
Right, so we're going to go back we're going to look at people maths, what you can do with actual people, which is a little bit more complicated at the moment. We've got some ideas for you to how to resolve it, but we're going to do that straight after the break.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you. On Relax Radio. Tune in to Relax Radio. Relax Radio.
Before we get started with the people maths, I do want to remind everybody that there are links to lots of further activities. There are links to our Facebook page, the AIMSEC SA Facebook page. All the links are in the description. And there's this one, Path to the Stars activity that you can see on the screen. There's a link to that. Just click on the link and it'll take you to lots more activities, including a home learning guide, an inclusion guide. So there are activities for teachers and schools, but there are also activities that you can do at home with a wide range, as in age 4. Well, actually there's no limit to the age, but there are activities that are aimed at 4-year-olds all the way to school leavers in the activity packs, and you can see the link on there, but there's a link to click in the description. So people maths. Well, people maths is one of the most engaging activities that those of us in the maths education world are always looking for activities where we can actually get the learners or parents or teachers to get hands-on and make the maths literally by moving around and using your body, using people to do the activities, rather than a manipulative on a table or on a piece of paper with a pen.
Yes, it's actually get on your feet and do it. Do the maths yourself with your body. That's people maths. Now here, this is a good example. Now, I don't know whether you can see my string, but you can. This is something you do with string.
Tony, we can stretch it out straight, but straight between both hands. We'll be able to see it.
Now, what Caroline meant when she said this is a little bit difficult now is because of COVID and people not being able to get together and social distancing. It's not an activity you could do right now, but it's there and it's a brilliant activity for better times. So you can do this with pencil and paper. But if you imagine this is a people maths activity, what you should do is imagine having the man with the face on his shirt has got a ball of string and nobody else has got any string. And then he passes that from the man with the ball, with the face on his shirt, he passes it across to this person with a spotty sleeve, all right? she passes across right to the other side to the person on the left. And notice it's gone 3 numbers or 3 points round. Now he passes it right across to the lady on the right, and then she passes it down, and then it goes up to not
Always
back to
passing
the
it to the
start.
third person. It's sending it 3 people along the circle,
And
around the
then
circle.
it goes on its path, right? I don't know. I hope you can see my cursor. And finally, the string gets back to the person who started off this, and everybody is holding a point of the star. Now, because this goes from 0, 3, 6, 9, 12, and so on, people can number themselves before they start, and then they can count around the lines of the star. And that's another way of counting in 3s, which gives you your 3 times table.
And it's a wonderful activity.
Now, I said, if you can't do this because of COVID or for whatever reason, or when you've done the actual people mass, you can give your children, you can give them a sheet like this, or they can just do it with pencil and paper and make their own dots. And you can see here that some of these instructions say join every alternate point, and some say draw every third point. But actually, when you've done that, you can experiment with joining every 4th point, or have more points around your circle and join any 5th or 6th. Anyway, it's something to explore, find out, try it.
And these, again, these circles, these points are in the home learning guide. So you can click on the link below and you can find these activities. Now, this is fun. This is another part of the game. Yeah, we're going to clap. I'm ready to clap.
And this is another fun way for children to learn their multiplication tables, develop number sense, mental arithmetic. Caroline, shall we do this?
Yeah, let's do it. Right.
Right.
Are you ready, Toni?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, we clapped on multiples of 2. That's the 2 times table.
So it's a similar principle to buzz fizz, except we're clapping instead of saying the word buzz or fizz. Okay.
Now, very small children can do that. As you know, if they can count up to 10, they can do the clap counting up to 10.
And this is a great way to start introducing the 2 times table without even mentioning the 2 times table. We're simply clapping every other number.
And then you can do another table. Should we do this one, Caroline?
Let's do it. Ready?
Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So what have we done?
That's the 3 times table. We've done the 3 times table.
Yes, yes. And then why stop at the 3 times table? You can do the 4 times table, or you can do this one. Caroline, shall we do it?
Shall we do that, or should we just go straight
we'll
to
just carry on.
alternating? Well,
Okay.
no, I was going to suggest that you do the 2 or the 3 or the 5, and I do, one does one does the other, just to demonstrate the next bit.
Well, you do the 2 and I'll do the 5.
Right.
Okay. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, I'm not sure whether it worked or not.
It did work, and what you want to do there is play this game and get them to observe. First of all, ask them beforehand, what do you think is going to happen? And then they will observe that sometimes everybody claps at the same time, and you're looking at what numbers are clapping at the same time and when. And so they're starting to find out the connections between effectively the different times tables. So it did work. It worked perfectly well. On 10, we both clapped. And then you ask when, where did everyone clap at the same time, or where was it loudest? Because you can do it with many different numbers. The older they get, the more you can actually work with lots of different numbers simultaneously and find out which numbers are the loudest, and get them to predict what's going to happen.
And you can do variants of this. I mean, I know a lovely activity called orchestra, where you actually only do it with 6 people. But instead of clapping, they jump in the air or something. And they can do it and sing at the same time. And this is why we call it orchestra. And we'll perhaps talk about that in more detail another time, but orchestra is brilliant.
I think we should get some volunteers and make a YouTube video of that.
Now, this one, the one we've just been talking about, what you've got, Group A is doing multiples of 2, Group B is clapping on multiples of 3, and Group C is clapping on multiples of 5. And the big question is, when will all the groups clap together? Now that's leading you into something that we call common multiples. And they're tremendously important when it comes to adding fractions. Anyway, yes. It's an easy way to learn about common multiples.
So important when it comes to adding fractions. Brilliant. Okay, after the break, we are going to look at skip counting and then find ways to help with those challenging, and yet they don't have to be, long multiplications. So see you straight after the break.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us, 24 hours, and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Right, we're on the homeward stretch here. Last 15 minutes, Toni. We've now got, we're getting into some really good, useful, it was all useful, but this is the answer to some really problems for some people.
With skip counting, it's really where we clapped in the clap counting. So skip counting is counting 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and so on, and you don't need to stop. Or counting in 5s, which people often find easier than a lot of other tables. 5, 10, 15, 20, 25, 30, 35, 40, and so on and so on. Now you can have we've got a table here. Those of you who are on the radio, we've got a table here where the multiples, I counted just now, are drawn across in rows, and above them we've got how many of them we're at. So that, for example, if we're counting in threes, across from 3 we've got 24, and above 24 we've got 8, which shows us that 8 threes are 24. So that table gives you the skip counting, and it also gives you something we call as two-way table. And of course we could have lots more rows in there. I just chose to show you an example with the multiples of 2, multiples of 3, and multiples of 5.
Yeah, we're just using the same numbers as we use for the clap counting. And the next part is something which I only encountered myself fairly recently, because I've only been doing the maths facilitation in the last few years, and we certainly didn't do this when I was at school. Can we see the next bit?
Oh, I was just going to.
Yeah.
What was I going to say?
I don't know.
Oh, I was just going to say little and often. So the secret for children is, don't make this drudgery, don't make it boring. Do the different things, clap counting, skip counting, other games, just for a short time, often enough. So soon the children know these multiplication facts without having to do any really hard work. But the truth of the matter is that if you're going to learn your part in a play, or you're going to learn, probably you learn the lyrics of a song by singing it, but you've got to do it over and over again. This is what you want to see, Caroline, and you can talk about it.
And sorry, now that Tony's mentioned that the little and often, it really works, especially the young learners. Get them a good foundation, get them playing the games frequently, keep improving, increasing the numbers, do it often and little and often, and you'll find that they just know their number facts.
But Caroline, you're talking about the little people, but I've coached 16-year-olds who didn't know their tables. And I just think they missed out in primary school. Just such a shame.
It's a remedy for older learners, such as myself, as I did not know my times tables. I've just been learning them recently to really get the fluency once I understood how important it was, and it's a great way to make sure that your very young learners don't ever have that problem. So it's a double remedy. The one of the things that, because I tutor children mostly aged 7 to 14, and one of the problems is understanding place value, understanding what they're actually doing when they're doing long multiplication and division. And that was the way I learned as well. I learned as a procedure. I didn't learn with understanding, not really. And even though I'm an electronic engineer, you can't do electronic engineering without maths, but there was a number sense, a fundamental number sense missing for me, and I'm still learning it. I'm loving becoming better and better at it all the time. Working with Toni and working with young learners, it's amazing what you have to learn when you're helping others learn. And this is such a beautiful way. And what it is it's a table. In this particular instance, we've got number 20 and the number 4 on the top row. We've got the number 70 and the number 5 on the left-hand column. Then what we're doing is we're multiplying 20 by 70. So all we actually have to do to multiply, and then that's going in a box below. All we actually have to do is multiply 2 and 7. 2 times 7 is 14. and then it's a matter of getting the place value right. So that's a separate conversation we'll have on a different live. But essentially with this table, because you've got 20, you've got the number 20, the number 4, the number 70, the number 5, all you actually have to do to know is the times tables to multiply 2 and 7, 4 and 7, 5 and 2, 5 and 4. You then put those numbers in the boxes and literally add them together, and then add, so you got 20 times 70 added to 20 times 5, and you get the answer to 20 times 75. So you then add go ahead and have a look at this. It's called a two-way multiplication table. You may have seen your children use it in school and gone, I really don't understand this. This is not the way I learned in school. What I recommend that you do is go and download the home learning guide. The link is in the description, and then really get to understand this yourself. Work with your child, they can help you understand it, and then together really get to grips on how this works. And the result will be that your young learner understands how to do long multiplication. And then, just to add a great kicker to this activity, you don't have to start with the big numbers. We've used the big numbers to show how you can really do. You can make them bigger. You don't have to stop in the tens. You can go into hundreds and thousands. You just add an extra column, and you're never multiplying more anything above the number 9 with another number. And if we go to the next page, Toni, what we've got is a bunch of puzzles. Now, this isn't the long multiplication, but what this does is this helps you fill in the blanks. All we've got is rows and columns, and you're looking for, you've been given 2 numbers, you've got to work out the third number. So you've got to do division, you might have to do division, you might have to do multiplication. You start with the numbers that the learner's familiar with, and then you make the numbers, just always stretch them a little bit. Start fun.
And it's a puzzle, isn't it, Caroline?
And, yeah, this is a puzzle.
You see, so A is part of the puzzle. And so what you have to do is to figure out what's happening with A, make the assumption that it's the same thing with each of the others, and fill the empty boxes. Yeah. And again, that link is not in the description, the one that's on there. So you would actually have to go to the website, follow the link in the description, and then search for the MD, the years 4 to that. But we will have all the links with when we put this a recording of this session, which we will shorten a bit and edit. On our YouTube channel, which is called Maths Toys, all these links will be there. Yeah, links will be there, on the Maths Toys YouTube channel. The last slide, because we haven't got much time, is important. And what you see on one side, maybe you can see which numbers are shaded sort of lilac colour. There's 6, 12, 18, 24, 30, 36, and so on. And what I was doing was skip counting in 6s, or if you like, I was talking about multiples of 6, and what you see in the picture is a nice pattern. This was another revelation to me. If you do it with the different numbers, and Toni's we're going to look at the next one, but if you do that with all the different numbers, you see different patterns. And again, you've got what you call the common factors, Toni, don't you? You can see where the common factors are, really visually, where the common factors are of the different. Well, what you can do is just have some fun, first of all, with the grid, like you see, it's got multiples of 6 in, but start with blank grids and take lots of copies of the grid, and in different ones, colour multiples of 2, and then multiples of 3, and then multiples of 4, and so on. And each one will be a different pattern. And then talk about, why is the pattern like this? Why have we got in the multiples of 6 these diagonal patterns?
And there are blank 100 squares in the main resource that is in the description right now. You can download and use the 100 squares.
Now the one on the right is important. We call this a sieve. A sieve, like you use to strain your vegetables.
Literally. Can I talk about this one, Toni? I was
well,
so
very quickly. We're running out of time.
Very quickly. All you need to do.
Well, all you do is you take the blank grid and you circle 2, and then you cross out all multiples of 2. And this one's done with a diagonal line. You'll see there's a diagonal line that's crossing out multiples of 2.
And then you all the way to 100.
Yes, and then when you go back to the beginning, the next number that isn't crossed or anything is 3. So you circle 3, and then you go to 6, 9, 12, 15, and so on. And you cross them out. This time it's the other diagonal. And then you go to the next number that isn't crossed out, and you circle it. It's 5. And then you go to 10, 15, 20, 25, and so on. And they're crossed out, this picture, with a horizontal line. The next one that isn't crossed out is 7. Circle 7. And then go to 14, 21, 28, and so on. And, well, here they're crossed out with a vertical line. And then you have a look at what you're left with. And you circle all the numbers that haven't been crossed out. But then when you try and circle the multiples of 11, you find that 22, for example, is already crossed out. So they go through and circle all the ones that haven't been crossed, and they are very special.
Except number 1. Except number 1.
Prime numbers, except number 1, which you can cross out any which way. It isn't prime. But the ones with circles around them are the prime numbers, and we've just gone up to 100. And in this learning pack, you'll find grids that go up to 200 and 400, and you can carry on this process. It doesn't take long. And there's one that only goes up to 36 for younger children.
And what that is really useful to know your primes, certainly up to 100, at least in the UK, because if you know your primes, there are lots and lots and lots of questions in the exams that you get given that if you know your primes, you've got the answer straight away.
Yes, I mean, it's just that number theory, working with numbers, primes are quite special. Mm-hmm. And when you come to do in school maths, things like factorizing and so on, it's quite useful if you can recognize a prime number when you see one.
Yeah, it is. Toni, that's all the time we've got for today. Thank you so much, everybody, for joining in. And we will see you next week for Happy Maths Hour at 5 o'clock London time. Thank you.
We hope you enjoy some of these activities.